Before we start digging into Neo4j and Cypher, it's worth looking at the history of graph databases. So what is the history of graph databases? Well, to answer that question, we need to look at the history of graph theory, which is recorded to have started in the 18th century. In 1735, a Swiss mathematician named Reinhard Euler solved a mathematical problem known as the 7 Bridges of Koenigsberg. The problem was to find a walk through the city that would cross each bridge once and only once. The islands, marked on the diagram here, A and B, could not be reached by any route other than bridges. Each bridge must have been crossed completely once during the walk. Euler proved that the problem could not be solved. The difficulty was the development of a technique of analysis that would prove that this was the case. First of all, Euler pointed out that the choice of route inside the landmass was irrelevant. The only important feature of the route was the sequence of bridges crossed. This allowed him to reformulate the problem in abstract terms, and this laid the foundation of graph theory. Euler replaced each landmass with an abstract concept of a vertex or node, and each bridge with an abstract concept of an edge. This enabled him to record which pair of vertices or landmasses is connected by which edge or bridge. The resulting mathematical structure is called a graph and is the foundation of graph theory and graph databases today. Euler discovered that the main advantage of graphs was that only the connection information is relevant. The pictorial view of the graph is irrelevant. It doesn't matter whether the edges are drawn straight or curved, or whether one node is left or right of another. Euler showed that the possibility of a walk through a graph traversing each edge exactly once depends on the degrees of the nodes. The degrees of the nodes is the number of edges touching it. Euler's solution of the Koenigsberg bridge problem is considered to be the first theorem of graph theory and the first true proof in the theory of networks. Today, graph theory has a very real and exciting impact on the database world, allowing us to store vast amounts of complex information in the form of graphs, and at the same time allowing us to traverse billions of nodes and edges at a consistent lightning speed. We can see such databases in action every day when we access Facebook, Google, Twitter, and many other social media sites. But the applications of graph databases don't stop there. Great gains are being felt in the financial world, in the world of banking and finance and insurance, and also in the medical industry. The future of computing owes a great gratitude to the amazing work of Reinhard Euler.